Here are the final two examples that I'm going to run through in this lesson. And the first one is magnesium sulfate. Now you'll notice that I've already built sulfate. The reason why is sulfate will always be built the exact same way. So sulfate SO4 is never built differently in one molecule than another. So I've put this together just like I showed you in the other video. Okay? So what's going to happen here, remember, sulfate is normally SO4 minus 2. And on the previous example, we didn't know where those two extra electrons came from, so I just put them down. In this case, I know exactly where those two electrons are going to come from. They're going to come from magnesium. This electron is going to go there. Now again, magnesium is a metal, so it's actually going to lose the electron. And then this electron is going to go right there. So that's why I'm showing them with arrows. Once I'm done that, I'm going to show my magnesium as a positive ion, and then sulfate with an extra electron there, and an extra electron there. And then I also have to do a double bond oxygen here. And one up here. And that would form a -2 ion. So again, the intramolecular bond, the thing that holds this entire molecule together, it's kind of interesting. I have double polar covalent bonds, 2 of them. I have 2 polar single covalent bonds, plus an ionic bond between the magnesium ion and the sulfate ion. And then the same thing would work for the structural diagram on something like this. We would go magnesium plus 2, sulfur, double bond, single bonded oxygen. It's in -2 ion. And then again, I'm not going to do the electronegativities because I've already done them. That's slightly negative, slightly negative, slightly negative, slightly negative, and sulfur is slightly positive. And that's how that one would go together. In the last example of the night, this is sulfuric acid. So again, the sulfate I've built exactly the same way that I've done in this example up here and on the one on the previous page. Now, again, sulfate needs 2 electrons to kind of complete it. So in this case, hydrogen is going to donate an electron here. Now you have to be careful. Hydrogen, even though it's on the metal side of the periodic table, hydrogen is a non-metal. So it's going to form a covalent bond. So I'm not showing an arrowhead here because they're actually going to join up. And then the same thing that's going to happen here. Now, when I put this together, sulfur, it has its original electrons there. Now, it's going to have oxygens around it. So I'm basically duplicating what I have. You'll see why I put the single electron down here on one like this and why it fits together a little easier. So then what I have to do is I have to show that there is a hydrogen that would be covalently bonded there and a hydrogen covalently bonded there. And then this whole thing, that's one molecule. So in this case, all the intramolecular bonds are covalent and there's no ionic bond. For electronegativity, I still have to do oxygen and carbon, or sorry, sulfur. And I would also have to do oxygen and hydrogen. Now both of these are polar covalent bonds, which means that the oxygens are going to be slightly negative. The sulfur would be slightly positive. We knew that before. And in this case, oxygen is slightly negative and hydrogen is slightly positive. So that'd be slightly positive, slightly negative, slightly positive, slightly negative, slightly positive, slightly negative up there for that oxygen, and slightly negative for that oxygen there. And that's how that would work. Structural diagram, basically double bond oxygen, double bond oxygen. And actually, this is really where I should have been doing the slightly positive and slightly negatives. If any of you were thinking that on the previous diagram, good for you. Slightly negative, slightly positive, and that's slightly positive. So you can kind of see that by putting them in this diagram, they kind of get lost with all the X's and O's. So even though I didn't mean to do that, it's kind of a lesson in why we don't put them there. It's not that it's wrong, it's just harder to see. On something like this, it's a little cleaner and it's a little easier to see. So there are your examples. Good luck on the bonding assignment. Take care.